In this section, I will show you how to set up a Raspberry Pi Zero with a night vision camera and a 7-inch touchscreen. This will allow you to see in the dark and capture images and videos with your Raspberry Pi. The night vision camera I'm using is the ZeroCam Night Vision, which comes with 2 IR LEDs and an adjustable focus lens. You can also use other night vision cameras for Raspberry Pi, such as the Articam Wide-Angle Day and Night Vision Camera or the Night Vision and Adjustable Focus Lens, 5MP. The 7-inch touchscreen I'm using is the official Raspberry Pi Touch display, which connects to the Raspberry Pi via a ribbon cable and 4 jumper wires. You can also use other touchscreens for Raspberry Pi, such as the Sunfounder 7-inch HD TFT LCD screen or the Elecro 7-inch touchscreen. To set up the Raspberry Pi Zero with the night vision camera and the touchscreen, you will need the following items. A Raspberry Pi Zero W or WH with a microSD card and a power supply, a night vision camera for Raspberry Pi with a ribbon cable, a 7-inch touchscreen for Raspberry Pi with a ribbon cable and 4 jumper wires, a mini HDMI to HDMI adapter and an HDMI cable, a USB OTG cable and a USB keyboard, a micro USB splitter cable, optional. The steps to set up the Raspberry Pi Zero with the night vision camera and the touchscreen are as follows. Download and install the latest version of Raspberry Pi OS on your microSD card using a computer. You can use the Raspberry Pi Imager tool or follow this guide. Enable SSH and Wi-Fi on your Raspberry Pi Zero by creating 2 files named SSH and wp_supplicant.conf on the boot partition of your microSD card. You can follow this guide for more details. Insert the microSD card into your Raspberry Pi Zero and connect it to a power supply. Wait for a few minutes until it boots up and connects to your Wi-Fi network. Find the IP address of your Raspberry Pi Zero by using a network scanner app on your phone or computer, such as Fing or Advanced IP Scanner. Alternatively, you can log into your router's web interface and look for the device named Raspberry Pi. Connect to your Raspberry Pi Zero via SSH using a terminal app on your computer, such as PuTTY or Terminal. The default username is Pi and the default password is Raspberry. You can follow this guide for more details. Update your Raspberry Pi Zero by running the following commands in the terminal. sudo apt update sudo apt full upgrade. Enable the camera interface on your Raspberry Pi Zero by running the following command in the terminal. Sudo raspi-config, then select interfacing options, then camera, then yes, then OK, then finish. You can follow this guide for more details. Connect your night vision camera to your Raspberry Pi Zero using the ribbon cable. Make sure the blue side of the cable faces the USB ports on the Raspberry Pi Zero and the camera board. You can follow this guide for more details. Connect your 7-inch touchscreen to your Raspberry Pi Zero using the ribbon cable and 4 jumper wires. Make sure you connect them according to this diagram. You can follow this guide for more details. Connect your mini HDMI to HDMI adapter to your Raspberry Pi Zero and connect it to your HDMI cable. Connect the other end of your HDMI cable to a monitor or TV. Connect your USB OTG cable to your Raspberry Pi Zero and connect it to your USB keyboard. Alternatively, you can use a micro USB splitter cable to connect both a keyboard and a mouse to your Raspberry Pi Zero. Reboot your Raspberry Pi Zero by running the following command in the terminal. Sudo reboot. After rebooting, you should see the desktop of Raspberry Pi OS on both your monitor or TV and your 7-inch touchscreen. You should also be able to use your keyboard and mouse to interact with them. Test your night vision camera by running the following command in the terminal. Raspastill o test.jpg. This will take a picture with your night vision camera and save it as test.jpg in your home directory. You can view it by double-clicking on it in the file manager or by running the following command in the terminal. eog test.jpg. You can also test your night vision camera by running the following command in the terminal. RASPAVID test.h264. This will record a video with your night vision camera and save it as test.h264 in your home directory. You can play it by running the following command in the terminal. onxplayer test.h264. You can adjust the focus of your night vision camera by twisting the focus band on the lens. You can also turn on and off the IR LEDs by pressing the button on the camera board. Congratulations! You have successfully set up a Raspberry Pi Zero with a night vision camera and a 7-inch touchscreen. You can now use it to see in the dark and capture images and videos with your Raspberry Pi. In this section, we will show you how to connect and use various sensors such as a compass, a temperature sensor, and a gyroscope to display data on the screen. These sensors will add some extra functionality and coolness to your night vision goggles. First, let's connect the compass module. We are using the QMC5883L module, which communicates with the Raspberry Pi using I2C protocol. To connect it, we need 4 jumper wires. Connect the VCC pin of the module to the 3.3V pin of the Pi, the GND pin to any ground pin, the SDA pin to GPIO2, pin 3, and the SCL pin to GPIO3, pin 5. Next, let's connect the temperature sensor. We are using the DS18B20 sensor, which communicates with the Pi using one-wire protocol. To connect it, we need 3 jumper wires and a 4.7K ohm resistor. Connect the VCC pin of the sensor to the 3.3V pin of the Pi, the GND pin to any ground pin, and the data pin to GPIO4, pin 7. Then, connect one end of the resistor between the VCC and data pins of the sensor. Finally, let's connect the gyroscope module. We are using the MPU 6050 module, which also communicates with the Pi using I2C protocol. To connect it, we need 4 jumper wires as well. Connect the VCC pin of the module to the 5V pin of the Pi, the GND pin to any ground pin, the SDA pin to GPIO2, pin 3, and the SCL pin to GPIO3, pin 5. Now that we have connected all the sensors, we need to enable I2C and one-wire interfaces on the Pi. To do that, open a terminal and type sudo raspi-config. Then, go to Interfacing Options and select I2C and one-wire. Enable both interfaces and reboot your Pi. To display data from these sensors on the screen, we need to write some code in Python. We will use some libraries such as SMBus for I2C communication, W1 Therm Sensor for reading temperature data, and Pygame for creating a graphical user interface. The code is too long to explain here, but you can find it on our website or GitHub repository. Basically, it does the following. It initializes Pygame and creates a window with a black background. It creates some fonts and colors for displaying text on the screen. It creates some functions for reading data from each sensor and converting it to appropriate units. It creates a main loop that runs forever and updates the screen every second. In each iteration of the loop, it reads data from each sensor and displays it on the screen in a nice format. The result is a cool overlay that shows you your heading direction, your temperature, and your orientation in real time. You can customize this code to suit your preferences. For example, you can change the fonts, colors, sizes, positions, or formats of the text. You can also add more sensors or features if you want. That's it for this section. You have successfully connected and used various sensors with your night vision goggles. Now you can enjoy seeing in the dark with some extra information on your screen. In this section, we will learn how to write and run custom code in C to control the night vision mode and the sensor overlay of our Raspberry Pi goggles. This will allow us to adjust the brightness, contrast, and color of the camera image, as well as display useful information from the sensors on the screen. First, we need to install some libraries and tools that will help us write and compile our code. We will use the Wiring Pi library to control the GPIO pins of the Raspberry Pi, the OpenCV library to process the camera image, and the SDL library to display the image and overlay on the screen. We will also use the GCC compiler to compile our code. To install these libraries and tools, open a terminal on your Raspberry Pi and type the following commands. Sudo apt update sudo apt install wiringp libopenk dev libstal 2 dev gcc. This may take some time, so be patient. Next, we need to create a folder where we will store our code and files. Let's call it NVG for Night Vision Goggles. To create this folder, type mkdir nvg cd nvg. Now we are ready to write our code. We will use a text editor called Nano to create and edit our code. To start Nano and create a new file called nvg.c, type nano nvg.c. This will open a blank file where we can type our code. You can use the arrow keys to move the cursor, and Ctrl+O to save the file, Ctrl+X to exit Nano. The code for our program is quite long, so we won't explain every line here. You can find the full code and comments on our website, link in the description. For now, we will just copy and paste the code from there into our file. To do that, open another terminal window and type wget https://diy-mag.com/projects/build_your_own_raspberry_pi_diy-nvg/nvg.c. This will download the code file into our NVG folder. Then switch back to the Nano window and press Ctrl+R to read a file into the current one. Type nvg.c and press enter. This will insert the code into our file. The code consists of several parts. The first part includes some header files that provide functions and definitions for our program. The second part defines some constants and variables that we will use throughout our program. The third part defines some functions that initialize and control the sensors, such as the compass, temperature, and gyroscope. The fourth part defines some functions that process and display the camera image and overlay using OpenCV and SDL. The fifth part defines some functions that handle user input from buttons or keyboard. The sixth part defines the main function that runs our program. After copying the code, press Ctrl+O to save the file, then Ctrl+X to exit Nano. Now we need to compile our code into an executable file that we can run on our Raspberry Pi. To do that, type gcc nvg.c onvg wiring pi lsdl2 lsdl2_ttf lopenv_core lopenv_improc lopenv_heidi. This will invoke the GCC compiler with some flags and libraries that are needed for our program. If there are no errors, this will create a file called NVG in our folder. To run our program, type /NVG. This will start our program and show us a live feed from the camera with a sensor overlay on top. You can use buttons or keyboard keys to control the night vision mode and sensor overlay. Here are some commands you can try. Press 1 or a button to toggle night vision mode on, off, press 2 or B button to toggle sensor overlay on, off, press 3 or X button to increase brightness, press 4 or Y button to decrease brightness, press 5 or L button to increase contrast, press 6 or R button to decrease contrast, press 7 or Z button to cycle through color modes. Normal, grayscale, red, green, blue, press 8 or C button to calibrate compass, press Q or ESC key to quit program. You can also see the values of the sensors on the overlay. The compass shows your heading in degrees, the temperature shows your ambient temperature in Celsius, the gyroscope shows your pitch and roll angles in degrees. You can adjust these values by changing some constants in the code, such as compass_offset, temperature_offset, gyroscope_scale, etc. That's it. You have successfully written and run custom code in C to control the night vision mode and sensor overlay of your Raspberry Pi goggles. You can now enjoy seeing in the dark and having a cool Iron Man style HUD. Have fun and stay safe.